Hi students, welcome to today's class. So today onwards I am going to explain the various models in covering all the syllabus of your JEE mains examination, which is going to coming from 24th of January. Okay now, so follow my classes and every day I will explain 5 to 6 problems. So every problem is a very important model which help you to get the answers in the JEE mains examination. So our aim is to answer the questions for 20 questions. At least 20 questions we have to write the correct answers so that we will get a good score in your mains examination. Okay now, so without wasting your valuable time, so let us start our class. So in this first problem, if one of the lines my square plus 1 minus m square xy minus mx square is equal to 0 is a bisector of the angle between the lines xy is equal to 0, then m is equal to. So try to read the problem carefully. If one of the lines of, in this lines it is a equation of pair of lines. It will have two lines. Okay now, in the two lines, one of the line is the angle bisector of the pair of lines. xy is equal to 0. It is also a pair of lines. Let us see then what is the value of m. So first of all, what we have to find out? We have to find out the bisector of the xy is equal to 0. Understand? Let us see the solution. xy is equal to 0. xy is equal to 0 means what? X is equal to 0 or y is equal to 0. X is equal to 0 means a y axis, y is equal to 0 means x axis. So this is the pair of lines are nothing but coordinate axis, x axis and y axis. So this is equal to y is equal to 0, x is equal to 0. Understand? We know the angle bisectors of these lines. So this is the angle bisector. So this is equal to y is equal to x. Another angle bisector is y is equal to minus x. Okay now. So therefore the angle bisectors are y is equal to plus or minus x. He is saying in this line, we don't know whether y is equal to x or y is equal to minus x, we don't know. One of the line is this has a two lines, no? In the two lines, one of the line is y is equal to x or y is equal to minus x. Then that means what? So this equation should satisfy the line. So this we are extracted the line from that pair of lines. That means what? So wherever y is there, you can substitute x or y is equal to minus x. You can substitute anything, you can substitute. Let us substitute in that equation. So therefore m into, in place of y, substitute plus or minus x. So plus or minus x means what? Mx square plus 1 minus m square into x into, in place of y, substitute plus or minus x. Then here plus or minus x will come, here x square will come. Okay now, minus mx square is equal to 0. Okay. So since x cannot be equal to 0, why? Because it is already given that x and y, one of the angle is pair of angle bisector. Okay, so we can cancel with so mx square minus mx square is equal to 0. Okay now, so this is equal to plus or minus 1 minus m square x square is equal to 0. This is possible only one, m square is equal to 0. Therefore m is equal to plus or minus 1. So m value is either plus 1 or minus 1. So in the options, option A is given as plus 1. Okay now. So very easy problem. This type of problems are also asking in JEE mains examination. Okay, I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. See here, the locus of the centers of the circles, which touch the circle x square plus y square is equal to 1 externally, also touch the y axis and lies in the first quadrant. Here our required circle is doing three major works it is doing. The first work is it touches the circle x square plus y square is equal to 1. That means this is the first quadrant and it is x-axis, y-axis, x square plus y square is equal to 1. So this is the circle. So this is the circle. X square plus y square is equal to 1 circle. That we know that the center is 0, 0, radius is 1. That is the first term. The locus of the center of the circle would touch the circle x square plus y square is equal to 1 externally. So our circle is touching this circle externally and also touches the y-axis and lies in the first quadrant. So that means the circle is touching this x-axis and y-axis and lies in the first quadrant. That means, so this is the required circle. Understand? So it is touching the y-axis. Touching the circle x square plus y square is equal to 1 externally and lies in the first quadrant. So this is the, now we have to know there are so many circles will come, such type of circles, so many infinite number of circles will come. So in that, according to that, the center also will change. So let the center be h comma k. So we have to find out the locus of the connecting the equation h and k. Let the center is this is a O dash and it is a O. So this is a radius. So this is a R1 and R2. Now let us see the solution. R1 is equal to 1. What is R2? What is R2? So if you see that the circle is touching y-axis. The circle is touching y-axis means what? It's the x coordinate of the center will become the radius. Okay, now that means what? So this is a h and it is k. Therefore, R2 is equal to h. That is the important point. So we know that R1. So this is nothing but O into O dash. O into O dash. O dash is equal to R1 plus R2. O dash means what? So this is the center 0, 0. Okay now. So distance between these two. O means how much? Root of h square plus k square is equal to R1 is 1, R2 is h. Let us do the squaring on both sides. Okay now. So this is a h square plus k square is equal to 1 plus h square plus 2h. So since h cannot be equal to 0, so it cannot be equal to 0. Why? Because the radius should be there or square. That's why we can cancel h. Therefore k square is equal to 1 plus 2h. Therefore k is equal to under square root of 1 plus 2h. Therefore, what is your k? hk. Now, while writing the equation, we will convert into x and y. Therefore, y is equal to root of 1 plus 2x. Of course, y should be positive and x should be also greater than or equal to 0. Why? Because the center lies in the first quadrant. Okay, now. So, therefore, clearly option B will be the correct answer. Okay. So, such type of analysis should be there. The one thing here analysis is generally students have to know means the radius of the second circle. So this is the second circle radius. Since it is touching y-axis, x coordinate of the center will be the radius. If it touches x-axis, for example, it touches the x-axis, it is a h comma k. What is y coordinate? K will be the radius. Okay, now. So if you catch that point, the problem will be very, very easy. Okay. I hope that you understand this solution. So let us go to next problem. Hi students, welcome to this third problem. Number of non-integral solutions of the equation x1 plus x2 plus x3 plus 4x4 is equal to 20. So first try to understand this problem. We have to select 4 numbers. You have to select the 4 numbers x1, x2, x3, x4. Then you substitute here and the sum should be 20. Then how many combination of numbers you will get? x1, x2, x3, x4 such that the condition is x1 plus x2 plus x3 plus x4, but all non-integral solution. Non-integral, not integers, that means you should not keep 1, 2, 3, so like that you should not keep. Non-integral, that means you have to fractional numbers you have to select such that sum should be is equal to 20. So if we want to do this problem, so we should know the multinomial theorem. So the number of non-integral solutions of this equation is same as the coefficient of is equal to how much here? There 20. The coefficient of x to the power of 20 in the expansion of so here x1 coefficient is 1 only, that's x1 coefficient, that means 1 minus x whole power minus 1. Here second x2, its coefficient is 1, that is equal to into 1 minus x whole power minus 1. x3 coefficient is 1, that's why 1 minus x whole to the power of minus 1 into, so this is a 1 minus x to the power of 4 whole power minus 1 is equal to 0. Understand? So not is equal to 0. In this expansion, that is 1 minus x whole power minus 1, 1 minus x whole power minus 1, 1 minus x whole power 4, 1 minus x to the power of 4 whole power minus 1. In this expansion, the coefficient of x power 20 is nothing but the number of integral solutions of this equation. Just to you go through the multinomial theorem. So let us see here. This is a 1 minus x power whole minus 3, 1 minus x power 4 whole minus 1. So you know the binomial expansions for negative integers. Okay, now so what is that expansion? This expansion is given by 1 plus 3c1 into x plus 4c2 into x square plus 5c3 into x cube plus 6c4 into x power 4 plus so on infinity it will go. Now what is the expansion of 1 minus x to the power of 4 power minus 1? So this is given by 1 plus x to the power of 4 plus x power 8 plus x power 12 plus x power 16 plus x power 20. Okay, now so that is a so on, it will also so on. Right, that we want up to x power 20, that we want. Okay, now so in this we have to select the x to the power of 20 coefficient. That means x to the power of 20 term you have to take. So first here, so if you multiply 1 into the last term x to the power of 20, so 1 into x to the power of 20, x to the power of 20, the coefficient is equal to 1. X into, if you multiply, say here x power 4, x power 8, x power 12, x power 16, x power 20. So here 4, 8, 12, 16, 20, nowhere you will get x power 20. So from this you cannot get x power 20. X square is there. X square means what? X square, there 18 should come. Here 18 should come. So x power 18 should come. So 18 it cannot come. Why? Because it is not a multiple of 4. That's why from this also you won't get. X cube means there 17 you have to get. So from this also you won't get. Understand? X to the power of 4, here x to the power of 16. So here 4 and 16. 4 and 16. Therefore plus 6c4. 6c4. Next one, this is equal to 7c5, x to the power of 5. X to the power of 20 will come. X to the power of 20, x to the power of 5 means here 15 have to come. So 15 it won't come. So like that. Again x to the power of 6. 6 means what? How much you have to get that side? 14. 14 also come, won't come. So if you go on calculating this, the coefficients you will get 6c4 plus 10c8 plus 12c10 plus so 12c10 plus next one 14c12. Okay, now so these are the again 18c, again you will get 18c14, again 20c16, 20c16, 20c16. Okay, now 8, 10, 12, 14, 16. So 18c16. 8. So here it is a 12 will come. So here 12c12. Check it here. 12c12, 4, 8, 12. So here 16 will come. So here 20 will come. Okay now. So this is a 18C. So 12, 6, 10, 14, 18, C 12. So if you calculate, so this you will get 536. Okay. So 536 will be the correct answer. Okay. So I hope that you understand this calculation. So let us go for next problem. Hi students, welcome to this problem. Let f is a function R to R be a function defined by f of x is equal to 2 into e to the power of 2x by e power 2x plus e. Then you have to find out f of 1 by 100 plus f of 2 by 100 plus f of 3 by 100 so on, f of 99 by 100 is equal to. Okay now. Then how to proceed this problem? Let us see here. Solution. So here it is given that f of x is equal to 2 into e power 2x by e power 2x plus e. Okay, understand? So 2 into e power 2x by e power 2x plus e. Better to find out f of 1 minus x also, that is a 2 into e power 2 into wherever x is there, substitute 1 minus x by 2 e to the power of 2 into 1 minus x plus e. Let us calculate that value. So that is equal to 2 into e to the power of 2 minus 2x by e to the power of 2 minus 2x plus e. Understand? Okay, that is a e power 1 is there. So this is a power m minus n, that is equal to 2 into e square by e power 2x by 2 into e square by e power 2x plus e. So if you take LCM, so what you will remain, e power 2x will get cancelled. Here e power 1 is there. 2e square by 2e square plus e to the power of 1 plus 2x. Understand? 2e square by 2e square plus e to the power of 1 plus 2x. Let us add these two results. What happens? Let us see that. F of x plus f of 1 minus x. What is f of x? This is a 2 into e to the power of. So we can write down 2 minus 2x by. So here denominator e to the power of 2 minus 2x plus e plus here 2e square by 2 times e square plus e to the power of 1 plus 2x. Okay now? Right. So if you simplify this, what happens? Let us see that. If you simplify this, all these things, if you simplify this, so we can take 2 common outside. We can take 2 common outside. If you take 2 common outside, so e square 2 into e to the power of 2 minus 2x by e to the power of 2 minus 2x plus e. In the numerator, you take 2 common outside, and 2e you take 2e common outside numerator. In the denominator, you take e common outside. Let us see what happens. So if you take 2e common outside here, so if you take 2e, already 2 came. If you take e also common, so this is equal to 2 to the power of 1 minus 2x. 1 minus 2x. Okay now? So already e power 1 minus 2x plus here already 2e came. So this is equal to 1e will remains by divided by denominator, just to take a e common outside. So here if you take a e common outside, what happens? E to the power of. So here e square, no, that means e power 1 minus 2x will come. So by this, if we add e power 1 into 1 plus 1, 2x plus 1 will be there here, plus 1. So here total plus will be there here, plus e divided by plus 1 here also. If you take a 2e common outside, if you take a e common outside, Okay, E common outside. What happens here? Only you are taking E common outside. So, this is equal to 2E plus E power 2E, E power 2x. E power 2x. Understand this? Okay, now let us see what happens. So, in the denominator also, here also, if you take this is a E will get cancelled. If you take the LCM here, e power 1 minus 2x plus 1 and 2 into e power 2x, if you take cross multiplication and if you do each and everything, these terms will be get cancelled and you will get 2. Understand? Let us try to do that. Okay, now. So, therefore, f of x plus f of 1 minus x value is equal to 2 we are getting. Okay. So, with that we will continue the problem. Okay, now. So, on the whole, if f of x is equal to 2 into e power 2x by e power 2x plus e, so we got the answer f of x plus f of 1 minus x is equal to 2 we got. Okay, now, right. Let us see this. Now, we have to find out this f of 1 by 100 plus f of 2 by 100 plus f of 3 by 100, so on f of 99 by 100, f of 99 by 100. Okay, now. Now, I will group total 99 terms are there, 99 terms will be there. So, we can group the two terms so that one term will be left over, that is f of 50 by 100, that will be left over. So, I will group the terms f of 1 by 100 plus f of 99 by 100. This is a one group plus f of 2 by 100 plus f of 98 by 100. This is a one group. Understand? So on, the groups will be there. Last one term is 50 by 100 will be there. So last here 1, 2, 3. So f of 49 by 100. F of 49 by 100 plus first term, this will be how much here? 1 plus 100. So, this is equal to f of 49 means what? How much? Here 41 by 100. Understand? So, not 41, 51 by 100. Okay, now. So, if you calculate all these values, so 100, 2 plus 100, 49 plus 50. So, last 50 by 100 that will be remain. See here, what we are going to do is this value is will come to how means, see here f of 1 by 100 plus f of 99 by 100. Can I write down 1 minus 1 by 100? Yes. This also f of 2 by 100. This can I write down 1 minus, sorry, this is 1 minus 1, sorry, this is 1 minus 1 by 100, 2 by 100. 100 minus 2, 98, so on. So on. Last f of 1 by 2 will remain, f of 1 by 2 remain. Okay, now. So what is this value? We got already f of x plus f of 1 minus x. This is value is 2. This value is also 2, 2, 2 like that. Up to here also 2 you will get. What about f of 1 by 2? If you want to find out f of 1 by 2, substitute in place of x 1 by 2. So, that is equal to f of 1 by 2 is equal to 2 into e to the power of, in place of x substitute 1 by 2, 2 will cancel, e by e to the power of, in place of x substitute 1 by 2, 2 will cancel, e plus e, both will get cancel 1. So, f of 1 by 2 value is equal to how much? 1. Now, total our sum is equal to 2 plus 2 plus 2 plus so on, 49 times are there, 49 2s are there. So, here 1, 2, 3, so on, 49 2s plus 1. F of 1 by 2 extra is there, no? That is 1. So, this is equal to how much? 49 into 2 plus 1. So, 49 2s are, so this is equal to 98 plus 1, total 99. 99 will be the, so it is integer type of question. So, 99 will be the final answer. Okay. So, dear students, I hope that you enjoyed today's class with some more very important model problems, and tomorrow's class I will stand before you. So, until then, all the best.